As you know, sensitivity analysis has been carried out using data tables in Excel for a long time. Although they are widely used, data tables have performance issues when multiple tables are used, since workbook calculations slow down. Also, the data tables formulas can't be manually edited. It's much better to use dynamic array formulas for sensitivity analysis because they don't have the issues that data tables have and they're much more flexible. Also, in these days when financial models are built using dynamic array functions and formulas, it makes sense to carry out sensitivity analysis using dynamic array functions and formulas too. Now, if you want to use dynamic array functions and formulas, you need to have Excel 365 with its new calculation engine. If you don't have Excel 365, you will have to use data tables for sensitivity analysis. So let's see how you can use dynamic array functions and formulas for sensitivity analysis. Here I'm in Excel and this is our Excel training app in the ribbon. The app enables you to take our courses on the Excel application itself. You can watch the lesson videos inside Excel and load practice files directly into the Excel application. Now I will use our Excel training app to load the data file to demonstrate using dynamic array functions for sensitivity analysis. So this is the demo file I'm going to use. I'm going to load that. So it's loaded onto the Excel application. So here I have a simple income statement calculated over here. So my assumptions are I have a price per unit of $7, cost per unit of $3.50, units sold or the quantity is 5,000, the fixed cost is 10,000, and the tax rate is 20%. So here I have calculated the income statement. Revenue is price per unit into units sold. Cost of goods sold is cost per unit into units sold. And the gross profit is revenue minus COGS. Fixed cost is taken from here. And the earnings before tax is gross profit minus fixed cost. And the tax, I have used the if function here. If the earnings before tax is positive or greater than 0, I'm going to calculate tax as earnings before tax into the tax rate. Otherwise, the value is 0 if it's negative. Then the net income is simply earnings before tax minus tax. So this is my basic income statement calculation, and I'm going to use sensitivity analysis for this income statement. So now I'm going to carry out sensitivity analysis on these variables for this income statement. So here I got a simple template here. The price per unit, I'm going to vary from $7 over here up to $10 and down to $4. So I just use these formulas +1 up to here and -1 down up to 4. So first we'll see how we use data tables for sensitivity analysis. So here I want to see how net income and revenue changes with the price per unit. So first thing I need to do is I need to insert the formula for net income over here. So I can take it from this cell over here. And for revenue, I can take the revenue calculation from here, C15. So this will be a one-way data table because we are only going to vary the price per unit variable here. So I need to first select the range like this, having the formulas for the revenue and net income and the variable values. So then I can go to data, what if analysis, and here we got data table. So it's asking me for the row input cell and column input cell. So the price per unit is as a column. So I will select that. And the price per unit, I will take it from this cell C6. And I will click OK. So the sensitivity table is already done, and these are the values I got. So as you can see, if you go to the formula bar over here, these formulas inside the data table cannot be edited because they are being generated by using the data tables tool. Now here we'll see how we can do the same thing using dynamic array formulas. So here in this sensitivity tables, I have used these formulas to calculate the price per unit ranging from 10 to 4. And here I have hard coded this 7 value. I have not referred it to the cell over here in the assumptions. That's because if you're using data tables, you can't have links to formulas inside the data table area. So we had to manually use this calculation formulas to do the range. But if we are using dynamic array formulas, we can use the sequence function to calculate the price per unit range. So I will type equals sequence, and I'm going to have 1, 2, 3, 4, 5, 6, 7, 7 values I need. So there will be 7 rows and only one column because I want all the data as one column. And the starting value, we can use price. So I have named this cell reference over here as price. So I'm going to have price plus 3 as the starting value, and the step will be 1. So here I'm going to use -1 because I want to reduce the prices. So I will close the bracket and press enter. So I got that whole range as before, 10 to 4, using the sequence function. And here the one benefit is that we can use this price from this cell reference over here inside the sensitivity table we are going to build, unlike in data tables. Now for net income, I need to again have a formula for net income. Here I can't link it from here because I'm going to vary the inputs for the price per unit inside the formula. So I will type the formula from scratch. So here if earnings before tax is positive, only I will be calculating the tax, and if not, I will not be adding the tax. So because of that, here I will need to start with the if condition when I'm calculating net income. So the if condition I'll be using is I will check whether earnings before tax is positive or greater than 0. If so, I will apply the tax. Otherwise, I will not apply the tax. So I can calculate the earnings before tax like this. So I will take price. I have named these cell ranges. So I will use the name price minus cost. So I have named that as well. So it will be price minus cost into the units sold. So units, and from that I will need to minus the fixed cost. So I have named it FC, fixed cost. So it's picking up from there. So all of these inputs are now there. And if this is the profit before tax, so if profit before tax, I'll put a bracket over here to separate it out. So if profit before tax is greater than 0, I will need to apply the tax. So I will just copy this range again, Control C and Control V over here. So if profit before tax is positive, greater than 0, I'm going to multiply that by 1 minus the tax. So that is the first part of the if condition, value if true. So this is the first part, logical test, value if true. So I need to put another bracket over here. And then value if true is this part. And then after the comma, I need to just put the value if false, which is the, again, just the profit before tax. Price minus cost. Again, I need to put a bracket here. And I can close the bracket. So I got 6,000. So the same value here. So here I had to do the formula. Yes. So let me move this here. So this net income formula looks a bit complicated because we have repeated the calculation for profit before tax 1, 2, 3 times. So in my next step, I will show you how to use the how we can use the let function to simplify this. So for now, I will just calculate the revenue as well. So revenue will be price per unit from K10. And I will use the hash operator to select this whole range. And that price per unit into units sold. So price per unit into units sold. So now I have created the sensitivity analysis for revenue, like I have done using the tables. So I will show you how to do the sensitivity analysis for net income in my next step. So here, for now, this is all you need to do to calculate the revenue sensitivity table, this simple formula. So here I will show you how to use the let function to simplify this formula and to do the sensitivity analysis. So here I'm going to write a formula equals, I'm going to use the let function over here. So you can use the let function to define a function or a formula and use that repeatedly inside your formulas. So here we had a long formula for the calculation of earnings before tax. So we can define that earnings before tax formula name and then the formula here and use it multiple times. So let me show you how to do that. So I'm going to define a variable called EBT. So that is the name one inside the syntax of this let function. So earnings before tax, I put a comma. That is the name of this variable, and name value 1 will be the earnings before tax formula that I created over here. So I just need to create it once over here. So I will use the formula I created earlier to calculate earnings before tax. So I will take price, and from that I will minus the cost, and I will multiply that by the units, and from that I will minus the fixed cost. So this is the same thing I did earlier, but here I'm going to calculate this once, and I will use it inside the if function using the variable name I'm creating here called EBT. So since I have created the variable name EBT, and I have given the calculation or the formula for that name value, I can put a comma now, and I can do the normal if formula I used earlier, but I will use the EBT variable name inside that formula to make it simple. So I will start the if function like this, a regular if function, and the logical test will be whether EBT, which I have now created, is coming there, is greater than 0. So since I have already defined what EBT is by giving this formula over here, I can just use the name of that created variable inside the if function. So if EBT is greater than 0, what I'm going to do is I'm going to take EBT and multiply by 1 minus tax. And that is the value if true, and the value if false will be just EBT. In case it's negative, there's no tax, I will just use EBT. And I can close the bracket like this. And since I started the let function with the open bracket over here, I will use the closing bracket and press enter. And I have calculated the same value I got over here. But now if I look at the formula, it looks much more simpler because I'm only using EBT long formula only once. Now inside this formula, I can replace the price per unit by giving that into the price over here, and it will calculate the sensitivities for me. I'll just copy the sequence function from here and use it over here. So same sequence function. So inside this let function for net income, I will replace price with this range over here from 10 to 4. So I will delete the price, and the range is starting from P10. So I will give P10, and since it's a spilled formula over there, the sequence function, I will use the hash operator and press enter. And I got the sensitivity values that I got from the data tables also created over here. And then if I want for the revenue, I can always start with the initial formula over here like this. Revenue will be price into units, and I can create the initial formula like this, and I can again replace this price with this range over here. So it's P10 and then hash. So P10, and I will use the hash operator to give the spilled area and press enter. And I got the same sensitivity table values generated over here. Now these formulas you can edit, unlike the sensitivity table formulas, and they are more flexible and it's easy for you to edit and change them. And also I have used the sequence function over here to generate the different variable value range that I want to use inside the sensitivity analysis. Now I'm going to do a two-way sensitivity table using price per unit on this side and cost per unit on this side. So the cost per unit from the original 3.5, I'm reducing it using these formulas by 0.5 up to down to 1.5, and I'm increasing it by 0.5 up to 5.5. And I'm going to use the same price range for the price per unit. So here what I want to create a sensitivity table is for the income variable. So I can just insert the income in the corner like this. So I have made the template for the sensitivity table. So I will select the range like this. Again, go to what if analysis, data table. So I have two variables that I'm going to change. The row input cell is what's there as a row, that is the cost per unit. So I can select that and select cost per unit from there. And the column input cell, what's there as a column is price per unit. So I will select the price from here. So once I've given the row input and the column input cell, I click on OK. And I have got the sensitivity table created. So here I have used conditional formatting to highlight the negative values. So these are the negative values where we are going into a net loss. Area over here, I'm going to do the same sensitivity table but using dynamic array functions and formulas. So first I will get the price per unit sequence using the sequence function. So equals sequence. So I need 7 rows, 1 column, and I will vary it from price plus 3. And the step will be minus 1. So I got the price changing from 10 to 4, same as before. And now I need to get a range for the cost per unit as well. So again, I will use a sequence function here, equals sequence. And here I will have only 1 row. So I put 1, and I'm going to have 9 columns or 9 cost per unit assumptions. So I'll put 9. And I will start with cost minus 2. And I will have a step of 0.5. So I got the same values as here. It's varying from 1.5 to 5.5. And this is our initial assumption. So this is our initial assumption. I will just highlight that with blue as well. So this is our template. So I can now create a sensitivity analysis table using dynamic arrays inside. Now I'm going to calculate a sensitivity table for net income. So I will use the let function again and the if function equals let, and I will first define the profit before tax. So I'll first create the variable PBT, profit before tax, and give the formula for profit before tax. So it's price minus cost into units minus fixed cost. Same formula I used before. And then I will do the calculation using the function if. So the logical test will be if profit before tax is greater than 0, value if true will be profit before tax into 1 minus tax. And the value if false will be just profit before tax. So since I started the let function with the open bracket, I need to put a closing bracket over here and press enter. So this is my initial profit before tax calculation. So now what I need to do is substitute the price range into the price, this one over here, and the cost I need to replace with the cost range over here. So I will delete price, and price is starting from J38 So J38, and I will put the hash operator to take the range, and the cost I will delete again. Cost is starting from K37, so K37, and I need to use the hash operator again, and I can press enter, and my sensitivity analysis is done, and it gives the same results as the data table, but this is much more flexible. So here you can, since we are using a sequence function, you can change the values over here, the ranges, and here also you can change the ranges, and inside you can change the formula if you want. So this is much more flexible than using the data tables. So let's look at a final example. So here we have made a DCF model for a company, and this is our NPV value over here, and these are the cash flows for the different years. And here I need to do a sensitivity analysis for the net present value using two variables, the discount rate and then the investment value. So in the input sheet, I have the initial assumptions. The initial investment is $6 million, and the discount rate is 9%. So I need to do a sensitivity analysis for the initial investment and then the discount rate. So I can come to the financial model over here. So first I'll create the discount range and then the investment range. Again, I can use sequence function equals sequence. So I will have only one row here, and I will use 5 columns, 5 discount rates, and I will start with the discount rate. I have given a name to that variable. So I have given a name to that input. It's called discrete minus 0.02 to reduce by 2%. And I will increase it by 0.01 or 1% as the step. So I got the range going from 7 to 11, and 9 is my initial assumption, so I will just highlight that 9. And here I want to have a sequence for the investments. Here I'll use the sequence function to generate the investment values. So number of rows, I will have 5 and 1 column. And the starting value I will take as investment minus 1 million minus 1 million, and the step will be 500,000. So it's starting from 5 million and going up to 7 million. And this is my initial 6 million input assumption. So I will highlight that with a blue color. So this is my template for the sensitivity analysis. So here I'm going to write the formula for NPV. So equals NPV. The rate, I will use discount rate. And for values, I will use the value range over here, and I will use the hash operator. And then I will have to minus the initial investment. So it will be investment. So 19,378,316. So that is our calculated value for the initial NPV. So here what I need to do now is I need to change the discount rate giving this range, and then the initial investment I need to change it by giving this range. So for the discount rate I can just delete that, and it's starting from L260. So it's L260, and I need to give the hash operator so that spill range is selected. And then for the investment I will just delete that, and I will use the investment spill range that's starting from A261, and I will use the hash operator and press enter. And this is my sensitivity analysis done. So since this whole model was done using dynamic array functions and formulas, it makes sense to do the sensitivity analysis using dynamic array functions and formulas as well. So this is how we can create a NPV sensitivity analysis using dynamic array functions and formulas. So I hope this was useful. Thanks for watching.
If you like our content and found it useful, I'd recommend you check out our top-selling Excel certificate courses. Our courses are designed to take you from a beginner to an advanced Excel user with comprehensive coverage of all the essential and advanced Excel features, tools, and functions. We focus more on modern Excel for data analysis and business modeling with Power Query, Power Pivot, and modern dynamic array functions and formulas to give you the best competitive advantage in today's demanding and fast-paced corporate world. We will also ensure that you are ready for the age of AI with our comprehensive coverage of Copilot for Excel in our courses. So, if you're interested in checking these courses out, head over to the links in the description below. You will get free access to our innovative Excel training app with all our courses. The app can be easily installed onto your Excel application from the Add-ins icon on your home ribbon. Once you add our app to your Excel application, it will appear on your ribbon. You can log into the app using the same credentials you used on our site for your course purchase. Once logged in, you can access all your courses from inside the Excel application. With our app, there is no need to watch tutorials outside the Excel application and come into Excel to practice. All lecture videos, practice files, and other resources are accessible from inside your Excel application thanks to our awesome Excel training app. You can load practice files directly to the Excel application without the hassle of downloading separately and opening in Excel to practice as you would need to do with other Excel training courses. Once you have loaded the practice file, you can watch the video tutorial and resize the video screen as required to watch and practice at the same time. Once you have finished practicing on an Excel file, you can clear it and load the next file to practice. The app will provide you with a unique and immersive learning experience with minimum distractions and hassle. We can guarantee it will be the best Excel learning experience you can have. So go ahead and buy a course and have a great learning experience with our Excel learning app. Now, if you like this video, why not subscribe to support us and get notifications so you don't miss any of our future videos. Thanks for watching, and I'll catch you next time.